This is E1.6 Rational Expressions and Equations, and we're going to talk about how to simplify rational expressions and also how to find the domain or the restricted values. Okay, the restricted or excluded values are the values that make the denominator 0. I'm going to go ahead and put that in here. Oops. The values that make the denominator 0. We don't want a 0 in the denominator because we can't divide by 0 parts. It's undefined. So that's the one time we have issues. So when we're solving these, we have to figure out what values would make the denominator 0 and then throw them out of our possible solutions. Okay? So we're going to go ahead and look at finding the excluded values here. All we have to do in order to do that is look at the domain or the denominator. Okay, since 3x is in the denominator, that means 3x cannot be equal to 0. So I just solved to see what value of x would make this equal 0. So it's the same as solving for the variable. So here I would divide both sides by 3, which tells me that x cannot be 0. So I'm going to exclude x equals 0. Okay, that's my excluded value. Let's look at another one. On this one, same idea. I look at the denominator. I say that 2x squared minus 3x cannot equal 0, and then I factor it. So here I can take out an x, and I'm left with 2x minus 3. And then since it's completely factored, I set each factor equal to 0 to solve for my excluded values. So this means x can't be 0, and 2x minus 3 can't be 0. Now x can't be 0 is already solved, simplified as much as possible. The other one, I need to move 3 to the other side by adding, which tells me that 2x cannot be 3, and then I divide off the 2, which gives me x cannot equal 3/2. So here I'm going to exclude x equals 0 and x equals 3/2. Okay, let's look at one more. If we look at this next one, it's a little bit different because notice when we look in the denominator, there's no variables, right? And really variables are the things that change our value. If there's nothing varying, right, then 6 is never going to change in the denominator. So even if I set 6 cannot equal 0, well, duh, 6 doesn't equal 0, and there's nothing I can do to 6 to change it into a 0. Okay, so here, I'm just going to put duh, 6 doesn't equal 0, which means that there's no restrictions. No restrictions. Or we can say no excluded values. Okay, either one is fine by me. Boop. Okay. Okay, so now what I want to look at is simplifying rational expressions. In order to simplify rational expressions, we check to make sure the top is completely factored and the bottom is completely factored, and then we can cancel common factors from the numerator and the denominator. Okay, and then just to refresh on what we did before, I'm going to go ahead and find the excluded values of these expressions as well. Okay, now when you find the excluded values, you always look for them before you start simplifying. Okay, so I'm going to go ahead and factor everything because that makes things easier. All right, so I'm going to go ahead and factor on top and bottom. On top, I can use sum product for this one. I need a sum of 5 and a product of 6. Now to get 6, I can use 6 and 1 or 2 and 3. Okay, but notice I need a product of -6, right? My 6 is negative, which means my signs have to be opposite. So I either need to do 2 minus 3, 3 minus 2, 6 minus 1, or 1 minus 6. The only of those pairs that gives me a positive 5 is if I do 6 minus 1. Now, because my leading coefficient is a 1, I can use my shortcut, which tells me that 6 and -1 are the numbers in my factored pair. So this factors into x plus 6 times x minus 1. Okay. Now I want to look at the denominator over here. First thing I do is take out my greatest common factor, which is an x. When I take out an x, I'm left with x squared plus 2x minus 3. And then I can do sum product with what's in here. If I do sum product here, my sum is a 2, and my product is negative 3. Since it's a negative, again, I need one sign of each, a positive and a negative. So I'm going to use 1 and 3, and my 1 needs to be negative in order to end up with a positive 2 when I combine them. Again, my leading coefficient is a 1, so I can use my shortcut, which says that the numbers that I found in my chart are the numbers in my factored quantities. So this one factors into x plus 3 times x minus 1. And then don't forget to bring down that greatest common factor. Okay. All right, so now this one is completely factored, and so is the top. So I want to go ahead and rewrite it and find my excluded values. Okay, so this gives me x plus 6 times x minus 1 all over x times x plus 3 times x minus 1. Now, before I start canceling, I have to find my excluded values, because if I cancel off one of my factors, I might miss one of the excluded values. So I'm going to go ahead and put over here, find excluded values before you cancel any factors. Okay, so I'm going to go ahead and set these not equal to 0. Remember, we take our denominator, set each factor equal to 0, and solve for the values we need to exclude. So this means x can't be 0, x plus 3 can't be 0, and x minus 1 can't be 0. So I need to solve the second two by subtracting 3, which says x cannot be negative 3, and then I'm going to add 1 to both sides, which tells me x cannot be positive 1. Okay, so for this one, my excluded, or let's just say I'm going to exclude x is equal to negative 3, 0, and 1. So these are the values I have to exclude. Now that I found the values I need to exclude, I can go ahead and simplify. Okay, simplify by canceling. Okay, so notice I have an x minus 1 on top and bottom, which leaves me with x plus 6 on top and x times x plus 3 on bottom. And I can just leave it like that. Okay, let's look at another one. Now this next one is a rational equation. If it's an equation, we still need to find our excluded values, but we can use our whole idea of clearing fractions to solve these. Okay, the last one didn't have an equal sign, so all we could do is simplify. When we have an equation, we can solve. So I'm going to go ahead and put up here, find excluded values first, then solve by clearing fractions. Okay, so the first thing I want to do is look at all my denominators and figure out what would make them 0. So when I look for my excluded value here, this means x minus 5 cannot be 0. So if I move my 5 over by adding, that tells me that x cannot be 5. And that is the only denominator I have, which means that I'm going to exclude from my possible solutions x equals 5. Okay, so now that I know what my excluded values are, I can go ahead and solve this. And the way that I solve is multiplying both sides by the least common denominator, which in this case is just x minus 5. Because notice this 4 on the other side is the same as 4 over 1. Okay, so I'm going to multiply both sides of my equation by x minus 5. Multiply x minus 5 on the other side. And the reason I'm doing that is so that these quantities will cancel. Okay, so that leaves me with x plus 4 on one side. On the other side, I'm going to go ahead and distribute that 4, so I get 4x minus 20. And now I can go ahead and solve. So I subtract x from both sides, which gives me 4 is equal to 3x minus 20. Add 20 to both sides, which gives me 24 is equal to 3x, and then divide off that 3. So I get x is equal to 8. And then you check your excluded value. Here the only excluded value I have is 5. So since I got an answer other than 5, I'm okay. So my solution is x equals 8. Let's look at another one. This next one, same thing. Always want to find my excluded values first. So my excluded values on this one, I look at my two denominators. This tells me that x can't be, This tells me that x plus 2 cannot be 0. So I solve it by subtracting 2 from both sides, which tells me that x cannot be negative 2. And then I look at this one, which says that x plus 4 can't be 0 because it's in the denominator. So I move my 4 to the other side, which tells me x cannot be negative 4. So the two values that I need to exclude are x equals negative 4 and negative 2. So if I were to get either of those answers, I cannot use them. Okay? So now I want to go ahead and solve by clearing fractions. So I look for my least common denominator, which in this case would be x plus 2 and x plus 4. So I'm going to multiply both sides by those denominators. So I'm going to do x plus 2 times x plus 4 times the left side, which is x over x plus 2. And then x plus 2 over x plus 4 times the right-hand side, which is x minus 5 over x plus 4. Okay. If you learn cross-multiply, this is the same thing. Notice when I reduce, my x plus 2's on the left and my x plus 4's on the right, I no longer have fractions. So on the left-hand side, I'm going to go ahead and distribute this x into that x plus 4. So I have x squared plus 4x is now equal to, and then here I need to distribute this. So over here to the side, what I'm basically doing is x plus 2 times x minus 5, and I'm going to distribute like that, okay? So x times x gives me x squared, x times negative 5 gives me negative 5x, and then I distribute the 2. 2 times x gives me 2x, and 2 times negative 5 gives me negative 10. Okay. Then I just need to combine all my like terms. So I have x squared plus 4x is equal to x squared minus 3x minus 10. Now if I wanted to start moving these all to the same side, notice what happens if I subtract x squared from both sides. Those cancel on both sides. And I'm left with 4x is equal to negative 3x minus 10. And then here I can just easily solve for x. Okay. So I'm going to add 3x to both sides, which gives me 7x is equal to negative 10. And then I divide off the 7, which gives me x is equal to negative 10 over 7. Okay. Which again is not one of our excluded values. Our only two excluded values were negative 4 and negative 2. So since we got something other than that, we're good. Okay. So there's a practice for y'all to try. Sorry that my writing kind of overlapped there. There's two for y'all to try, and then I'll go over them. Okay, so I went ahead and made a little pink line to kind of separate the last problem that I went over a little bit from our practice. On the first practice problem, when we look for our excluded values, we set 5x plus 2 equal to 0 or not equal to 0 and solve, which means our excluded value is x equals negative 2/5. Once we know our excluded value, then we go ahead and multiply on both sides by our least common denominator, which in this case is 5x plus 2. When we do that, the 5x plus 2 cancels, and I'm left with an equation that no longer has fractions. I gather all my x's on one side, all my constants on the other, and then divide off the coefficient of my x, and I should get x is equal to negative 5 over 29. Okay. On the second one, I find my excluded values first. When I find my excluded values, I set x minus 4 and x plus 5 not equal to 0, which means I need to exclude positive 4 and negative 5. And then I go ahead and solve by clearing fractions. My least common denominator in this case is x plus 5 and x minus 4. So that's what I'm multiplying on both sides of my equation. Okay. Notice that my denominators on both sides cancel out, And what I'm left with, I then need to multiply out. So I distributed the x to the x plus 5, and then I FOILed the x minus 4 and the x plus 1. After that, it's just a matter of getting all your x's on one side, all of your constants on the other. When I solve, I get x equals -1/2. Okay, and I do want to mention, on none of these did we end up with an answer that was one of our excluded values. Okay, if you get an answer that is an excluded value, then your solution would be no solution, because we can't use excluded values. Okay. All right, so that is the end of E1.6. So you should now be able to complete the E1.6 exercise and your My Math Lab homework. Okay.